Okay, now let's discuss about quadratic relation that will shape a parabola. So we are still talking about the same general form of quadratic relations, but when I put b equals 0, it will shape a parabola, which will have a different orientation when I put a equals 0. So let's go head to head to this situation. Now, first, when I put the b equals 0, it means the quadratic relations will be like this. Since I lose the y square, the b, since the b equals 0. But if I put a equals 0 and the other b, c, d, e are any integers, so I will have this kind of situation. These both equations will shape a parabola, but will be different. So let's see one by one. If this is the case, b equals 0, the general form, if I put it into the general form, it will be y equals ax squared plus bx plus c, which is very familiar with you. We have already covered this on chapter 4, and this is a quadratic function. So yes, it will shape the parabola that we have already known. We use the smiley or sour face, okay, or facing upward, facing downward. So what's the difference with the parabola on the right side? The general form, since we lost the x square, but we still have the y square, so this is the general form. We just flip the x and y position. So this one, it will be x equals ay squared plus by plus c. Okay, it's clearly visible the difference here. And then let's talk about the vertex. If I convert this general form into a vertex form, we will have this kind of form, and you have already known that. So how about the right parabola? The right one will have this kind of vertex forms. So since on the left parabola we have y equals ax squared, so the vertex form begins with y minus k, and the inside the square will be the x. But for the right parabola on the right side, since the general form x equals something, so the vertex form you need to present with x first also, x minus h, and then you can see it on the screen. So what is the vertex? The vertex coordinates will be h comma k. Okay, so when I present you this kind of form, you can directly extract what is the h, what is the k, and yes, you get your vertex coordinate. What about the parabola on the right side? So it's still the same. The vertex will be h comma k. So after you finally found this form, you can directly extract dh as your x coordinate of your vertex, and the k will be your y coordinate of your vertex. Okay, so now how about the formula? Since we know that we have already learned two methods to find the vertex. First, by converting into a vertex form, or by using the formula from the general form. Since the formula, I will just discuss briefly. You have already known this. So find the h or the x coordinate of your vertex. You just use the minus b over 2a, the b from here and the a from here. So how about the k? You can actually substitute to the general form after you find the h, or you can use minus d over 4a. What is d? D is the discriminant. If you need to remember, discriminant equals b squared minus 4ac. Okay, so next, how about parabola on the right side? So if I have this kind of parabola, the formula of finding the vertex will be flipped. What I mean is, look at the h. When you want to find the h or the x coordinate of your vertex of your parabola, the formula will be minus d over 4a, or minus b squared minus 4ac over 4a. So it's different from the left side. The formula for your h for the left parabola will be the formula of your k for your right parabola. How about the y-intercept? The y-intercept from the left parabola will be very easy, since y-intercept is the coordinate of your parabola when the x equals 0. So you just substitute your general form, x equals 0, then you can just find that the y coordinate will be c. So your y-intercept will be very easy to get, which is 0, c. How about the right parabola? It's almost the same, but not for the y-intercept, for the x-intercept. Why? Since the x-intercept is the pair or the coordinate on your parabola, when the value of y equals 0, it's easier for you to find it on this kind of general form, since when you substitute y equals 0, then you just can finally found that x will be equal c. So for the right parabola, it's very easy for you to find the x-intercept, which is c, 0. So on the left, the harder one will be finding the x-intercept. Okay, so for finding the x-intercept, you know that there are about three cases. Okay, but I will just make it 4. First, before we find the x-intercept, let's find what is the condition of the x-intercept by calculating the discriminant. So you know that when the discriminant is bigger than 0, b square minus 4ac is bigger than 0 from the general form, of course, abc-nya, and it is perfect square, it means you will have two x-intercepts, and the x-intercept value will be rational numbers. So the method to find the x-intercept, if this is your case, you can use the quadratic formula, which is the general method, or you can use factor, since we will have rational numbers for your x-intercept. And the second case will be if the discriminant is bigger than 0, but not the perfect square. It means you will have still two x-intercepts, but the value of your two x-intercepts will be irrational numbers or radicals usually. And then what about the third case? The third case, if d equals 0, then you will have one x-intercept, and that value will be rational number. You can use either quadratic formula or factoring in looking for the x-intercept. The last one will be when d less than 0, we have no x-intercepts on your graph, or if you calculate it, you will find two imaginary numbers as your x. So that is the x-intercept for the left parabola, which you have already learned from the previous chapter, quadratic function. So on the right side, which is not a quadratic function, this is a quadratic relation. So to find the y-intercepts, it's the same. The discriminant is b square minus 4ac. Find it from the general form. This is the a, this is the b, and this is the c. So after you substitute it into the b square minus 4ac, and then you find the value, and if it is bigger than 0 and it is a perfect square, then you have two y-intercepts with rational numbers value. And if it is bigger than 0 but not a perfect square, you have still two y-intercepts, but the value will be irrational numbers. If it is equal 0, then you still have one y-intercept with the value of rational numbers. And the last one, the d less than 0, then you have no y-intercept. Or if you want to find the value of the y-intercept, it will be two imaginary numbers. So after we find the situations of the conditions of your x-intercept on the left or y-intercepts on the right, so let's find what is the value of your x-intercepts. You have already learned two methods, which is factor completely and find the zeros, which is applicable only for the first case and the third case, since we have rational numbers as our x-intercepts. Or the second one, the more general one, using the quadratic formula, since it is applicable for all of these situations. By using the quadratic formula, you can have the value of x1 or x2, or just for any x-intercepts. Either it is, or the x value, either it is rational numbers, irrational numbers, or even imaginary numbers. The discriminant itself, yes, I've already told you that it is b squared minus 4ac. So how about the right parabola? So it's the same. Finding the value of your y-intercepts will be two methods. First, factor completely and find the zeros only for the first one and third case. And the second one will be the y1 and y2 using minus b plus minus square root of d over 2a from the general form. Okay, the b, a, and c, you get it from the general form here. So after we have this, of course, you want to know more about what is the shape, the difference between the parabola on the left and the parabola on the right. So actually, yes, you can see here on the left, when you have this kind of general form, if the a is less than 0, it's facing downward. If it is greater than 0, facing upward. Different with the right one, if you have this general form, which is x equals ay squared plus by plus c, if the a is bigger than 0, then it will face right. If it is less than 0, it will face left. Remember, it's not the hyperbola. We just choose either one, either a less than 0 or a is greater than 0. You will have only one parabola. So for further explanations, I will show you example. Let's first discuss about the graph. If we have this kind of equation, the quadratic relation, which is also the quadratic function that we have covered before on chapter 4, if a is, for example, this one, if a is greater than 0 and there is no x-intercept, like this one, we have the discriminant of this equation, of this graph, will be less than 0. But the y-intercept will be 1. It will be up there, okay, since the curve of your parabola will continually goes upward. So eventually it will cross the y-intercept. And about this one, okay, for example, we assume that the vertex of this parabola is really on the x-axis. It means this parabola, or the equation of this parabola, will have one y-intercept here and only one x-intercept, which is on the vertex. So if you check the discriminant on that equation, you will find the discriminant equals 0. And the last one, if we have, for example, like this, now we have a parabola which has one y-intercept here and two x-intercepts here and here. So if we calculate the discriminant, it will be greater than 0. So for the opposite, if we have that a less than 0, we have this kind of curve, this kind of parabola with a less than 0. So it's the same. If this is the case, eventually it will have two x-intercepts because eventually it will go here and here. Since it has two x-intercepts, the discriminant, if you check it, it will be greater than 0. The y-intercepts will be 1. If we have this situation, for example, you have only one y-intercept and one x-intercept. The discriminant will be 0. And the last one, if this is the case, you will have y-intercept 1 coordinate just down there. Okay, we have faith that it will continuously go closer and closer and intersect the y-axis. But about the x-intercept, it will be none. Okay, since there is no cross-sections or intersections to the x-axis. So the discriminant of this equation, this graph, will be less than 0. Okay, now if we go to other type of parabola, which is this one is the quadratic relation, not function. Now the equation, the general form will be like this: x equals ay squared plus by plus c. Now if this is the case, the x-intercept that they always have one x-intercept. Different than the before, they always have one y-intercept. And so the x-intercept will always 1, like this. This is still 1, only 1, even this, even here, anywhere you put the vertex, the parabola will always have 1 x-intercept. But how about the y-intercepts? The y-intercepts can be, can be 3 different cases. For this one, we don't have y-intercept, so the discriminant of this equation will be less than 0. Okay, if this is the case, for example, the vertex will be right on the y-axis. Let's assume that this is on the y-axis. It means only 1 y-intercept, so the discriminant will be 0. And the last one, if this is your parabola or this, okay, we still have 2 y-intercepts. The discriminant of your equation must be greater than 0. So just like for this one, this is facing right, so the a will be greater than 0. So all parabola that facing right will have this general form with a positive. For this one, this is facing left. This is a parabola with this general equation, but the a must be negative, so it's facing left. So it's the same. This one, it will has 2 y-intercepts, and only 1 x-intercepts. Since it has 2 y-intercept, the discriminant of the equation must be greater than 0. If this is the case, right on the y-axis, it has only 1 y-intercept, so the discriminant will be 0. And the last one, for this kind of parabola, there is none y-intercept, and the discriminant must be less than 0.